Yes. Today is 3rd September. The homework number 4 is due. It's tonight. And I think the homework number 5 is the 6th. That is the Sunday midnight, right? Because I posted the review homeworks. Number 6 is an additional one here. It's due Tuesday. So because of that, I posted the homework number 5 is due Sunday midnight. So please do number 5 in this weekend. And today, we are going to discuss the homework number 4 and homework number 5. So first of all, I want to do the question number 4. Let me open it bigger in another software. So let me copy, paste. Okay, just a second. Yes, it is number 4 in homework number 4. Yeah, here's a question number 4 and homework number 4. Basically, in homework number 4 and 5, we discuss probability. So in this question, we tossed a dime 3 times. So we have 3 outcomes. The very first one, we have a head for the first one, and head again for the second one, and even the last one would be head again, right? So when we toss 3 times a coin, then we can consider 8 possible outcomes, and the set of the 8 possible outcomes, we just say is a capital S, and it has a name, the sample space. So now, based on the sample space, we can take some probabilities. So in part A, take a probability, all 3 are heads. We have only one outcome, is head, head, and head. They are all 3 heads. So we have only 1 out of 8. So we have to plug the fraction. It's 1 out of 8. Let me check. So 1 out of 8. Yeah, it's good. And part B. So now the part B, we need another probability. The first 2, we tossed 3 times, and we just focus on the first 2, the first one and the second one. It doesn't matter what will be the third one. And the first 2 is a head, right? So here's a 1, not this one. And here's the other one, and not that one. So we have 2 outcomes out of 8. But my labs suggest us simplify. So it must be 1 out of 4. So your answer is 1 out of 4 in part B. It's good, right? And let me try the part C. Yeah, we can do, it's a case by case. We take the probabilities. Now, all 3 are same. So we have only 2 cases, the 2 outcomes. Head, 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 tail, tail, and tail. So we have another 2 outcomes out of 8. Simplify, 1/4 again. So when you take the probability, yeah, you just count. How many the case? Out of, from the sample space. It's always is out of 8. Let me finish. It's part D. Find another probability. Just focus on the second one. Yeah, it's again, we toast the 3 times. Yeah, ignore the first one and the third one. Just focus on the second one. It must be tail. So it's not this one. Yeah, here's a tail, second one. Not this one. And tail here, the second one. Not that one. Tail in the middle. And tail in the middle. How many? 4 out of 8. Simplify. It will be 1/2. So basically in chapter 4, we discuss the probabilities, but simply we just count is how many outcomes for the event and out of the total number of outcomes in the sample space. So you can try by yourself and the others. And definitely if you have any question, yeah, you can ask me. And I want to go to, it's number 9. Yep, here's a number 9. In number 9, we need a probability E or F. In chapter 4, probability, in chapter 4, we are going to have 2 cases. And, for example, it's E and F. The other one, E or F. So please remember the 2 cases. We can make a Venn diagram. Have you ever heard the Venn diagram? Right? It's somewhere we have a problem, the Venn diagram. The Venn diagram has a rectangle. It is the sample space, the big S. And we have 2 events, E, F, and is in the middle. E and F in the middle. However, or, okay, let me make the Venn diagram again, the rectangle, sample space, event of E, event of F. Now the or means E or F. So simply we just add the left one and the right one, and additionally the in the middle. So we just combine the 2 events. That is the or. So we have 2 cases. But now in number 9 is ask us the or. But we have to understand what is the meaning of the mutually exclusive. It is a very special case. It's not looks like this, the Venn diagram, but when they are mutually exclusive, we can make the 2 circles, E and F, is a separately. So when they are mutually exclusive, but we need the probability A or B, but still we combine them together. So we need the probability of E separately, we need the probability of F, but they are given here. So now the probability E, here. Yes, here. It will be simply probability of E add probability of F, because they are mutually exclusive. They are separated. So I just add 0.41 and 0.51, then the answer will be 0.92. It is the probability of E or F. It's a 0.92. Textbook, name this one is the special addition rule. Because it is a special case and we added the two probabilities. So the name is the special addition rule when they are mutually exclusive. But now, let me go to number 11. Here's a number 11. Yeah, it's the same thing. We need a probability E or F, but it doesn't say they are mutually exclusive. So generally, I have to make the Venn diagram. Here is a E, and there is a F. And now we need a probability E or F. Right? Simply, I just add the two probabilities. So here is a E, 0.30, the blue one. And here is a F, 0.40, the green one. When I just add the two probabilities, it's actually I added twice in the middle. I added in the middle twice. So when they are not mutually exclusive, the general case, we have to subtract the middle. How did I describe the middle? E and F. So it's not only add the two probabilities, but now when they are not mutually exclusive, we subtract the middle probability, the common area, E and F. And here is the probabilities given here, the E and F. So simply I just plugged probability of E, 0.30, probability of F, 0.40, minus E and F, which was a 0.20. So let me see, it's a 0.5. So the final probability, E or F, that will be 0.5. Does it make sense? The textbook name this a general. Yeah, it is a general case when they are not mutually exclusive, but we added, so it is a general addition rule. We have two kinds of addition rules. One was a special case when they are mutually exclusive. It's a separate case, it's a two groups. But now it is a general one. And let me apply the general addition rule is onto the number 13. So now let me try at number 13. Here's an event, female. So let me make the Venn diagram. Here is a female. 52.1%. Now let me ask you, who all is outside? You know, actually the rectangle was a sample space. It's all possible group, right? Yeah. So who are outside of the female? We have a male, right? So simply in the circle, inside, there is a females. How many percentages? 52.1%. But outside, there is a males. Can you guess how much is the percentages of the males? I can say it will be 47.9%. I'm sorry, I don't have a space to. How did I get this one? Because the whole sample space is 100%, and subtract is a delete females. How much? 52.1%. That will be the others, males, 47.9%, right? So simply, from the percentages of the female, yeah, we can take the other percentages of the males. Yeah, it's like this way. And now we have another group. It's a diverse. Yeah, I put the other group, the other event is a diverse. And now, who are in the middle? Diverse, female. Does it make sense? Because in the middle is an and, so female and diverse, the diverse female. Who is here then? There is a female, but not diverse. Does it make sense, right? How about this one? Diverse who? Diverse is outside of the female. So it's actually here. That is the divorced male. Then how do you think here? Male, but not divorced, right? So case by case, it's a partition by partition. Yeah, we can interpret. We should understand who are here and who are there. Good, right? Okay, now, yes, 6.4% is a diverse female. That is in the middle. So now, probability of female, yeah, it was given, but it suggests us answers as a decimals. So it will be 0.521. And the next question is, what is the probability of divorced? Probability of D, yeah, was the 10.1%. So you should answer as a 0.101. And the third one will be the end in the middle. End, yep, is a divorced female, was given 6.4%. So the probability female and divorced is a 0.061. So that is the 6.1%. Okay, yeah. And now in part B, it's an OR. In part B, we need a probability. It's not AND, but OR. And now we can apply the general addition rule, which will be the probability of F, probability of D, we add separately, and then subtract in the middle, F and D. They were all given 0.521 plus 0.101 minus 0.061. Oops. Yeah, I'm sorry, the last one is a 61. So let me try. As a 0.521 and 0.101 and 0.061. The answer will be 0.561. That will be the probability, female or divorced. Okay. It's not only divorced female, but also it's not divorced female, divorced male. Right? Yeah. So that is the probability, F or D. You can try the other questions in homework number 4 by yourself. And if you have any question, please email me. Okay. So let me finish the homework number 4. And let me try the homework number 5. Okay. Is homework number 5. It is another questions, it's another topics in chapter 4, the probability. Let me try the question number 1. As I told you, the homework number 5 will be due Sunday midnight. Okay, yeah. In this question, we can make the cross table, right? So here is the overall total. So when I add these two subtotal, it must be 30. So the second total, it must be 18. So 12 and 18, and now we can make the 30. It's the same thing. When I add these two cells, 3 and this one, it must be 12. So now I need the second column, the second cell, it must be 9. So 3 and 9 must be the 12, the subtotal. It's the same idea. This way, it's a something and the 7, it must be 18. So the first one must be 11. 11 and 7 will be 18. And now, it's a column-wise, add up. Then the subtotal will be 14, 16, 14, and 16. That will be 30. Okay? So in part A, it's a fill up the missing cells in the cross table. It's a 2 by 2. And now, we can take the probability of C1. Now the C1, here is a 14. So the probability C1 this way is that there is a 14. The subtotal is all C1s. It's out of 30. I think it's probably my labs is a suggest to you is to simplify the fraction. So it will be 7 out of 15. And the next one is R2. It's R2 here, this way. So we have to take the 18. So it's a probability of R2. That is the 18 out of, it's a 30 again. So simplification will be 9, 15, and one more time is a 3 out of 5. And now this one is end. That means, oh my God, I mess up. Let me use the purple one. C1 and R2. So we have to take the middle case, the C1 and R2, right? It's a crossover. Then we take the 11. So the probability C1 and R2, then we take the count in the middle. It's combine them together in the middle because the end was in the middle, the common area in the Venn diagram. So take the 11 out of 30 again, and we cannot simplify. Yeah, it is, right? So now I call them, yeah, I just take the subtotal as a marginally is here, right? Here, there. So the first two, they are the marginal probability. But the last one is the something and the other one is actually, it is the joint probability. So in number 1, yeah, we discussed the table and we discussed the joint probability or the marginal probability. Okay, so please understand the table, the structure, and please understand what is the joint probability and what is the marginal probability. So now we can use the marginal probability and joint probability is practically. in number 4. The reason why we need the marginal probability and the joint probability is actually because of the conditional probability. So now it is the conditional probability. We can read it. It is a conditional probability of F given E. Okay, yeah, here's a bar, and we read it given. By the formula, by the conditional probability rule, it will be same as the probability of F and E over probability of E. You know, actually the probability of E was given. So now I can interpret the numerator, F and E, it is a joint probability. And the denominator, it's just E, it is the marginal probability. In another question, you might have the table, and you can take the joint probability and the marginal probability. Finally, you can be asked what is the conditional as a probability. But anyhow, here we have the joint probability and we have the denominator. So simply we just take the ratio 0.4 over 0.5. We need the decimals, so we have to try. It's a 0.4 over 0.5. It is a 0.8. The 0.8 is the conditional probability. So let me check. Let me check the answer. Number 4 is a 0.8. It's good, right? So simply take the joint probability at the top and the given probability, or probability of the given event at the bottom, and just to take the fraction, it will be the way to get the conditional probability. Okay, yeah. So please try the other problems. And now here's another example for the conditional in number 9. It is the question number 9. Let me see. Okay, here it is. Here's the probability. 72.3% is a bachelor degree. And this one is another one. It's a 36.6 that was a bachelor degree awarded the women. So now I can take the other probability of bachelor, and now I can interpret the bachelor and awarded the women. It's a joint probability. It will be the 36.6%. Okay, so now we have a marginal probability and the joint probability. And the question is, what percentage is what? The bachelor degrees is awarded to women. You know, actually, it is not clear. But the question is, what is the conditional probability? The proportion of the women among the bachelor degree. Okay, so please read the question carefully again. What is the percentages? the bachelor degree is awarded to women. So I can interpret, yeah, we need the conditional probability of women as given the bachelors. Okay, then by the formula, by the conditional probability, it will be the joint probability, women and bachelor is divided by the bachelor, the given event. So let me plug the joint probability up there, 0.3, 6, and 6 divided by the marginal is a 0.723. So it will be 0.366 over 0.723. It will be how many decimals? It's only one decimal. So I have a 0.51. That is the conditional probability. So let me check. Oh, it's a percentages. I'm sorry. Just a second. It's not this one. Actually, I have a 0.5062 with the percentages. It must be 50.6%. It must be 50.6%. Okay, with the one decimals. So let me check the answer. It's a 50.6%. It's good, right? So yeah, we take the joint probability at the top. I'm sorry, here, joint one and the marginal one, and the marginal one must be given, yeah, before, okay. And now I want to try as a number 12. Let me go to number 12. At the beginning, I told you we had the two cases, and or, right? It's already for or, the E or F, we apply the addition rules. We have two kinds of addition rules. One was the special one. And the other one is the general one. And now we need another rules for AND. For AND, yeah, now it's A and B. Yeah, it doesn't matter. It's A and B or E and F. It doesn't matter. Yeah, we just name it. The AND, then we just apply the multiplication rule. Multiplication rule. What do you expect? We are going to take the multiplication. And we have two cases. The special one and the general one. Now the number 12, it is the special, the general one. So if I need the probability A and B, simply we just take the multiplication, the probability of A times the conditional probability of A. And the event over here, it must be given in the second probability. So now this number 12 is a very simple example to apply the general multiplication rule. Yeah, simply just multiplication. But you have to know the single event of A, it must be given in the conditional probability. So now I just take the multiplication 0.6 and 0.35. That will be the answer. So let me try. It's a 0.6 times it's 0.35. That is a 0.21. You might have another probability, but simply just to take the multiplication then you can take the probability A and B. So we can apply the multiplication rule. But now, let me try the number 13. This one is a special case. Before, when we discuss the special addition rule, they were, I'm sorry, just a second. Yes, they were mutually exclusive. But now, the special case, they must be independent. Independent means when we have a conditional probability A given B, they are independent. So the conditional probability A given B will be same as just A, because they are independent. So because of that, the special case, the special multiplication rule for the probability of A and B, the general case was the probability of A times the probability of B given A, but now they are independent. We just ignore it, because the conditional probability will be exactly same as the first one, just B. So now in number 13, we had a probability of A, separately just B. Just simply take the multiplication. It's a 0.2 times is a 0.9. That will be 0.18. Let me check. 0.18. Okay. So now I can summarize. Yeah, I think the Zoom meeting will be end in 1 minute. Yeah, I almost done. So we have two cases. It's and or, and each of them has two cases: the special one and the general one. So please finish the homework number 4 due tonight, and number 5 by Sunday. And any question, please email me. So let me end the Zoom meeting. I'm sorry, we don't have enough time to get the answers, get the questions. So please email me. Let me end the Zoom meeting. Thank you for coming.